So I'm going to write my steps sequentially in this side just to kind of show that I'm not moving this around. I'm going to try to get this left side to equal cotangent squared. And I'm not going to expect you to write sentences out of explaining what you do, but when we do something that involves one of our identities, we're going to just write it next to it, okay? So what could I do first to the left side? And what are you thinking? So let's distribute the top. So we do that, and we get 1. And I don't even want you to write that part down. When you have a sum and a difference like this, we should know that the middle terms are going to cancel, right? All right, so I'm left with 1 minus sine squared of u.
Is there a reason that we're using u?
Yeah, just for a new letter.
Oh, okay.
So you get used to, so you don't get confused when they use different letters for variables, okay? U just still represents an angle, so it could be theta, it could be x. Sometimes you'll see other Greek letters in there. Sometimes we see y, but no. Is there a really special reason we're using U? It's just a variable. So. All right, so now here are some things that might be tempting. You might try, oh, I'm going to divide by both things by sine squared. Okay, well, you could do that if you wanted. Basically, at some point, it's going to involve probably a Pythagorean identity because of the squares in there. Okay, so Aiden says what?
Cosine squared.
What's cosine squared? The top. So the first Pythagorean identity is sine squared plus cosine squared equals 1. So isn't 1 minus sine squared equal to cosine squared? So we're going to replace the top then with cosine squared u over sine squared u. And what did we use? A Pythagorean identity. So we're going to just write that on the side there. It's my justification. And that's really all there is to it, because what's cosine squared u over sine squared u equal to? Cotangent squared. And what did we use to get there? What tells us that on our trig property sheet? Yeah. And you don't have, the only ones you have to memorize are the Pythagorean. Use your trig property sheet, so have that out. So this is a quotient identity. All right. So then do you see that I have this? Yeah. Okay. So what can I put here if I want?
Ooh, a black box.
Well, it doesn't have to be black, but it's whatever color you're making. I didn't even hear Carmen, so.
What? Oh. I missed you, Mom.
Molly's easily amused this morning. All right.
So cool.
Aiden doesn't do the proof part. He just puts boxes at the ends of all his problems. All right. There's not going to be any points awarded, by the way, on the test, just for the black box. Sorry. Well, that's good. I'm glad you're finding something you like about it. All right. Example 2. We're going to try to prove that 1 over 1 minus sine of x plus 1 over 1 plus sine of x equals 2 secant squared x. Okay. So sometimes on proof it's kind of hard to decide what do I do? Where do I start? Do I rewrite things? I will tell you this, if you have fractions, I would at least try to get the fractions together. Okay? And so if you run into a dead end, you could always go back to the beginning and try something else, but that works a lot of the time. So these, how would I get them together? Because they don't have a common denominator right now. Could I get a common denominator? Let's put parentheses around them, okay? So to get a common denominator, what could I multiply this fraction by? This one's already 1 minus, so let's look at the other denominator. Couldn't I multiply by 1 plus sine of x? Is that what you said? Sorry. Over 1 plus sine of x. And then how about this one? Yep. 1 minus sine of x over 1 minus sine of x. Okay. So now I'm going to actually simplify those expressions. So on the top, 1 plus sine of x over 1 is still just 1 plus sine of x. Let's try multiplying the denominator together. What do we get? 1, because we FOIL, right? The middle terms cancel again. 1 minus sine squared x. Ooh, that's something. Then over here, 1 minus sine of x, and we know we had the common denominator, so. Wait, what?
Sorry.
It's okay. I'll wait. Are you with me so far? So the point of doing the common denominator is so we can put the numerators together. So if I added, and by the way, I didn't write anything down here. I have not used any trig properties yet. I've just multiplied, okay, and done a common denominator. Add the top expression together. What do we get? We have 1 plus sine plus 1 minus sine. So what does that simplify to be? Well, 1 plus sine plus 1 minus sine is 2. Okay. 2. Now, can I do anything with the bottom? Yes. This is a Pythagorean identity. What's 1 minus sine squared? Cosine squared. So now since I did use a Pythagorean identity, I'm just going to put that in this spot on the right. Because I used one of my trig things. Okay, keep in mind here, guys, that's what we're trying to prove. Isn't this the same as saying 2 times 1 over cosine squared? Isn't that the same thing? Okay. What is 1 over cosine squared? So I'm going to write 2 times secant squared x, and I used what property says that 1 over cosine squared is? Yep, reciprocal property. Alright, so then since that was what I was trying to prove, we can put the back.
What if you don't solve it, just put my box?
No. No box. Okay. So, one thing I want to point out to you is that what happens when we've seen this up here. This it was given to you, but do you see how 1 minus sine, if I multiply by 1 plus sine, then I get a Pythagorean identity. And here, when I happened to multiply by the common denominator, it happened again. 1 plus sine, 1 minus sine, and I got 1 minus sine squared. That's actually a strategy we're going to use a little bit more tomorrow, but I'm going to show you one more example where we're actually going to do that to get a Pythagorean identity. And you can do it as long as you do it to numerator and denominator. So,